Welcome to electron configurations homework. All right, so the first question is, how many valence electrons? Now remember, valence electrons are the electrons on the outside of an atom. And on your super awesome periodic table that I gave you, it is these numbers here at the top of the columns. All of the elements in column 1 have 1 valence electrons. All of the elements in column 2 have 2. We skip this valley. These are called transition elements. We're going to skip those, and we're going to go over here. All right, these ones here each have 3, 4, 5, 6, 7, and 8 valence electrons. The only exception to this is helium. Helium is unusual. It has only 2 electrons, and they're on the outside, so it has 2 valence electrons. But we put it in this column because it acts like a noble gas and does not act anything like beryllium and magnesium. With that in mind, let's try number 1. Let's find out how many valence electrons does aluminum have. That's element 13, which is right here. It's in column 3. So the answer is therefore 3 valence electrons. Xenon is here. It's a noble gas, which means it has 8 valence electrons. Then we have calcium, element 20, is over here. It's in column 2. Therefore it has 2 valence electrons. Starting to see a pattern here. We have fluorine, element 9. It's in column 7. Since it's in column 7, it must have 7 valence electrons. And finally, we have the oddly named bismuth, which is in column 5, and therefore it has 5 valence electrons. Now when we're asked how many energy levels an atom has, that's the numbers that go down the side of the periodic table. We call this the first period. It has one energy level. These all have 2 energy levels. These all have 3 energy levels, and 4 and 5 and 6. And we've got to be a little bit careful because when we get to here, we look here, these here have 6 energy levels, and these ones here called the actinides have 7. So be a little bit careful when we get asked about those. Let's move this back down here. Alright, so how many energy levels do the following elements have? We'll start with aluminum. Aluminum is here. It's in period 3, so it has 3. Xenon is here. It has 5 energy levels. Calcium, element 20, is here, and it therefore has 4 energy levels. Fluorine is here, element 9, and it is in the second period. It has 2 energy levels. And the oddly named bismuth has 6 energy levels. Let's move on here and say, okay, how many electrons can each of the following sublevels hold? So sublevels, basically you just have to commit this to memory. What we have is this. S has 2 electrons it can hold. And remember, the S part of the periodic table is here. So you have 1s and 2s. Helium we put over here. Then we have the P's. There are 1, 2, 3, 4, 5, 6 p electrons. Then we have the D's, which are here. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 d electrons. And then we're going to take a look at the F's, which are down here. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of those bad boys. So we have 14. Now I know a lot of you won't like this next section here, 3. The question is, circle the air in each of the following electron configurations. So to find electron configurations, you basically just go across the periodic table, filling in each sublevel that you come to. So first you fill in the 1s, and then the third electron is going to come over here into the 2s. And after the 2s, the 5th electron is going to go here in the 2p. And after you fill in the 2p, the 11th electron comes over here into the 3s. And then after the 3s, we come across and we put the 13th electron here in the 3p. And from there we go to the 4s. And from the 4s we go right here. If you look real carefully, this is actually the 3d and then the 4p. And that's how we fill it. And you always fill one before you go to the next. That's one of the rules. So s's can hold 2, p's can hold 6, d's can hold 10, and f's can hold 14. And you always fill one before you go to the next. So let's just try this. 1s2, yep. From there we should fill in the 2s, but look, we only have one. So our problem here is that is a problem, that we should have filled that S sublevel before we went on to the 2p6. Let's try the next one. 1s2, no problem. 2s2, no problem. After the 2s2, we come over here and we put in the 6p electrons, but look what we put here. We can't have 7 p electrons. There's only 6 of them. Try the next one. 1s2, no problem. 2s2, no problem. 2p6, no problem. After that, we go over here to the 3s2, no problem. Here we go to the 3,6, no problem. And then this has us going to 3D, but if you look, after you fill in the 3p, what we should do is we should come over here, and the 19th electron should go into the 4s. The 4s fills before the 3d, and it's because the 4s sublevel requires less energy to be in than the 3d. Think about my parking garage analogy. So therefore, the problem here is 3d should not come before 4s. Try the next one. 1s2, no problem. 2s2, no problem. 2p6, no problem. 3s, 3p, 4s, 3d, no problem. But look at this, we got 8p electrons? I don't think so. You can't have 8p electrons. You can only have 6. Try the next one then. We have the 1s. What's this 1p? There is no 1p. All right, let's try our next one then. We have here, for each of the following pairs, determine which sublevel would fill first. All right, so you just had to go across the periodic table. So let's find 3d and 4s. Here is 3d, and here is 4s. The 19th electron would go in the 4s, and the 21st electron would begin filling the 3d. So therefore, the 4s is what would fill first. And now, the following pairs, which would fill first, 2p or 3s? Well, here's 2p, and here's 3s, so we would fill the 2p before we came over here and fill the 3s. You know, I'm just going to circle it. So the answer would be 2p. Now for the next one, 3d or 4p, let's see. Here's 3d, and here's 4p. So the 3d fills first. The 21st through 30th electrons go there, and the 31st one goes into the 4p. So therefore, the answer is 3d fills first. And the 5f or 7s, let's just see here. 5s or 7f, let's just try this. Here is the, this is the, we're going to make this larger here, whoops. You look, here is the 5f is right here, and here is the 7s. So actually, the 7s fills before the 5f does. So let's move this down. So the answer in this case is 5f. For the next ones, all right, let's get into the thick of it here. This is really what this assignment is all about, how to write electron configurations. So we have to do sulfur, which is element 16. That means we have to park 16 electrons totally to fill in a sulfur. Now, we could start with the 1s and put 2 in it and the 2s, but that gets kind of tedious. So what we do is we always consolidate using a noble gas configuration. To find the noble gas that you'll consolidate with, the easiest thing is simply to go up and over and say, I'm going to use neon. Basically, it has to be the largest noble gas with a number that's smaller than the one you're filling. So the easiest way through most of the periodic table, except for the F block, is to simply go up and over. So in this case, I'm going to use neon, and I can't write it quite that small. So I got neon, which should be in brackets. All right, and that's, if you look, neon is element number 10. So I've just by doing this, I've taken care of 10 electrons. Where does that 11th electron go? Well, here's electron number 11. It is going in the 3s. Remember, these are the s's, the p's, the d's, and then the f's are the ones that are down at the bottom here. All right, so after I fill in these 10, which are right here, I go to the 11th electron in the 3s. 3s. And I'm going to park 2 electrons in it. I'm going to park one here and one here. Now that gets me up to number 12. Where's my 13th electron going? It's going here. This is the 3p sublevel. So I write 3p. Now let's see how many electrons I'm going to park. Remember, I'm trying to get to sulfur, so I had to park 1, 2, 3, 4 electrons in that sublevel. Alright, let's try vanadium then. Vanadium is element 23. I got to park 23 electrons. Here's element 23. So to consolidate with a noble gas, I go up, I go over. I'm going to use argon because it is the largest noble gas before you get to element 23. So by writing Ar here, Ar, I have just taken care of 18 of my electrons. So the question I show is, where does that 19th electron go? Here it is. The 19th electron goes in the 4s sublevel. It holds 2 electrons, 1, 2. Now after I fill that, look where I go next. I just filled in the 19th and 20th electrons here by filling in the 4s. The 21st electron goes here, and if you look right here, what you're going to see is it says 3d, not 4, 3d. So it turns out the 4s is easier to park in than the 3d is. So after the 4s, then you start parking in the 3d sublevel. And how many electrons am I going to park? Well, I'm going to park 1, 2, 3 to get to vanadium. So I'll have 3 electrons in the 3d sublevel. Alright, the next thing we have to do is neodymium, which is element 60. I need a little bit of room to get to that one here. Alright, neodymium, where are you? Element 60, there you are, my friend. Alright, so I had to park 60 electrons. So in this case, I just can't go up and over. That doesn't work. So what I had to say is, what is the largest noble gas that has less than 60 less than 60 electrons? And it's right here. Element 54 is xenon. So I'm going to consolidate neodymium by putting Xe. And when I put that Xe, I have just taken care of 54 electrons. The 55th electron is right here. It's going to the 6s sublevel. And I'm going to park 1, 2 valence electrons there. Now just follow this. After I fill that, I'm going to come down here and fill these. And this, if we look right here, we see what we're filling here is the 4F. It takes less energy to park in the 6s than it does to fill in the 4F. That's why this fills first. But after you fill 6s, then you begin moving into the 4F sublevel. And how many electrons am I going to park there? 1, 2, 3, 4. Let's try lead. Lead is element 82. Here's 82. I got to park 82 electrons. In this case, I just go up and over. Again, I'm going to use xenon, which will take care of 54 of them. That's 54. Where does that 55th electron go? It goes here. Oops, I did that wrong. It goes right here in the 6s. So I'll say 6s2. After I fill that in, I'm going to come down here, and now I'm going to fill in the, if you look here, these are all 4Fs. And if I count across, there's 14 of these rascals. So I'm going to say 4F14. Now, after I finish that, where does that leave me? Well, I've just filled in 70 electrons. The 71st electron goes here. And if I look real careful, I'll see it's in the 5D. So now I'm starting to fill the 5D sublevel. And how many am I going to park? Well, I'm going to go all the way across the D's. And that's, if I count, there's 10 of those. And then finally I get over here and I start filling. So starting here, I'm moving into the P. So I look here, that's 5D. This is 6P. So I'm filling in the 6P, and I have to do 2 of those. This one here and this one here. So I have 6P2. Great. Alright, on to berkelium, element 97. 97 is way the heck down here. Now again, I just can't go up and over, so I say, what is the largest noble gas that has less than 97 electrons? And it's right here, radon. So I'm going to put brackets Rn. And in doing that, I just took care of 86 of these electrons. The 87th electron is going to go here in the 7s sublevel. And I'm going to put in 1, 2 electrons. Then after that, I'm going to go from here. I'm just going to follow this down. Oh, look, I'm going here to the 5F sublevel. And how many electrons am I going to park there? I've got to get all the way over to berkelium. So I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. Did that look like a 9? I can't tell. That did not look like a 9. Let's try that again. That's supposed to be a 9. All right. Starting to get the idea here. I hope you are. Let's try moving on here. I hope it'll let me do it. No, let's see here. All right, let's do tantalum then. Element 73. Element 73 is right here. So I go up and I go over. I'm going to take care of 54 of them by writing xenon. So I'm going to put xenon. That took care of 54 electrons. The 55th electron goes here in the 6s sublevel. And I'm going to put in 2 electrons. After the 6s, I have to come down here and fill in the 4f. Now I can tell that I have to go, if I'm going over here to tantalum, I know I have to go all the way across here. I could count if I want and count to 14, but I can also just remember there are 14f electrons. After I do that, that brings me over here to, I've just took care of 70 of them. The 71st one is going in the, what does that say? That says the 5D. And how many electrons am I going to park there? I'm going to park 1, 2, 3 of them. And last but not least is bromine. Bromine is element 35, which is here. So I'm going to go up and over. I'm going to write AR. In writing AR, I just took care of 18 of my electrons. The 19th electron goes here in the 4s sublevel. And I'm going to park 1, 2 of them there. After the 4s, that gave me my 19th and 20th. The 21st electron went here into the 3D. And I'm trying to get to bromine, which means I have to go all the way across the D's, and that, if I count them, I'll find there's 10 of them, or I can just memorize there's 10 D electrons. And that gets me to here, to element zinc, which is 30. The 31st electron is going to go here in the 4p. And I'm trying to get to bromine, so how many 4p electrons are there going to be? There's going to be 1, 2, 3, 4, 5 of those bad boys. Hey, and you're done with your homework. That wasn't so bad, was it? You know what? It just takes practice. After a while, it'll almost seem fun. I'm not even kidding. See you later.